Alright guys, so today we are looking at a different way of measuring an angle. So let's first talk about what an angle was from geometry. So we learned from geometry that an angle is formed by two rays with a common endpoint. Squeeze up here, a common endpoint, and that common endpoint was called a vertex. So we measured it using degrees, but degrees ends up being something that is inconvenient to use just because we're going to explore angle measures that are beyond 360 degrees. So if we're talking about angle measures that are like 720 degrees, it's much more easy to convert it to a different unit of measure that is much smaller in magnitude. So we call that new unit of measure called a radian. We call it a radian. Okay, before I jump to what a radian is, we're gonna just briefly talk about how we define angles or name angles. So you might have remembered naming angle, that angle to the left as angle ABC or angle theta. Okay, so that symbol right there is a lowercase Greek letter for theta. Okay, sometimes the angles are named after Greek letters, and that is a common one as well. That's beta. And then you have here alpha. So all common names, especially as we move further into trig. Okay, so we learned last year about arc length, and arc length is the length of an arc. So if you take a look at the circle below, this is an arc. An arc you would define as just a piece of the circumference. So I'm going to go ahead and write circumference here. Okay, and so a radian measure is defined from the definition of what an arc length is. So going back to arc length, we have that 1 radian is the measure of the central angle whose arc length is the same as the radius of the circle. So let's go ahead and sketch what that means. So let's say in that circle, we go ahead and draw the radius in to form that this is the length from the center to A and to B is equal to R. And if I were to measure out arc AB, that arc is also equal to R. Okay, and so what we then define as a radian is the angle measure in there is 1 radian. Okay, so if you think about the arc length formula itself, the arc length formula itself is S equals R theta. And so if I'm saying that the arc length is equal to R when theta is equal to 1, then the definition right here is that this measure is equal to theta equals 1. Would mean that 1 radian times R is equal to the length of that arc, and S is the symbol, so this is the symbol for arc length. Something else to observe also is the fact that you have the circumference formula from geometry being 2 pi r. That if I'm defining let's say that we define the radius to be from a unit circle, and a unit circle is a circle with a radius of 1, that if I substitute that radius measure of 1 into that formula, I get that the circumference is 2 pi long, or the arc length itself is 2 pi. Okay, and so the arc length of the entire circle is 2 pi, which is equal to the measure of the central angle from what you remember from geometry. Well, now we get that the radian measure, what we've previously associated with a full circle, full revolution of a circle being 360 degrees, is equivalent to 2 pi. Okay, and so we get that the entire circle has a radian measure of 2 pi. Then what is the measure of half a circle? A half a circle, if I divide both sides by 2, is, we know it's 180 degree revolution, is then equal to pi. So we're going to go ahead and fill in that box. That's going to be a key conversion factor for us. So if I'm given any angle in degree, we want to be comfortable converting between degree to radian and then also from radian to degree. So it's the same as when you guys are doing unit conversion in science or in previous math classes. If you have a specific angle measure measured in degree, so I'm just going to put a box around this. So this is, let's say, the given value that you have. Okay, and so that angle measure is first given to you in degree. And if I want to convert this to radian, I'm going to go ahead and multiply it by the equivalence of pi. And think of it's currently in degrees and I want to cancel out degree. Well, pi is equivalent to 180 degrees. So I'm using this knowledge right here, the conversion factor being pi over 180. And pi and 180 are equivalent to each other. So you're essentially multiplying by 1. Okay, now if I wanted to, and I'm going to go ahead and switch colors here. If I wanted to go from radians to degrees, you're given an angle measure, but this time the angle's in terms of radian. And usually we don't have to write radians. If you just write an angle measure without the degree symbol, it's assumed to be radians. So you have the angle measure and you want to now convert it to degrees. What you're now going to do is switch that fraction, that conversion factor that we have over there to 180 over pi. And so if you think about it, it's like the radians cancel each other out and then you are left with the degrees on top. Okay, and so that's going to give you guys the answer here. And I forgot to put the box on the other one as well. So this would be your answer here. Okay, so let's do an example. And some of these you'll just come to remember or to memorize it as you guys do the problems. But below here, I'm going to start you guys off with 1 or 2 and then have you guys go ahead and finish up the rest. So radian, let's say 60 degrees, if I want to go ahead and convert it to, so 60 degrees, if I wanted to convert that to, so degrees to radians, I would multiply by pi over 180 degrees. And so we see 60 goes into 183 times, so 60 degrees is equivalent to pi over 3. Okay, now if I wanted to go backwards and do it to where I want to convert 5 pi over 4 to degrees, I would this time multiply by 180 over pi. And so this is easy to see that the pi's cancel out. And if you multiply across 5 times 180 divided by 4, you get a degree measure of 225 degrees. Okay, we want to be careful, I would say, on values like this where they're asking you guys to convert a radian that doesn't have any pi in it to degrees. Remember, you're still multiplying by 180 over pi. This time you just don't have a pi to cancel out, so it's 360 divided by pi. Which we get a value of, actually we'll just leave it for now, 360 over pi. I actually do, let's go ahead and let me show you guys something on your calculator so you do know where to find this. Let me go to Desmos as the calculator. Okay, if you guys are using Desmos or any sort of scientific calculator, you should see a function on the, for Desmos, it's in the upper right hand corner. If you click on the little wrench symbol right there, at the bottom there's a if you'll notice here, there's radians versus degrees. So you see me toggling back and forth. So you want to be aware that on your calculator you want to be in the appropriate unit measure when you're dealing with trig, whether you want to tell the calculator to recognize the angle as a radian measure or as a degree. And on most scientific calculators, there's that option to toggle back